Alright, so we've gotten our first three. Let's move on to the next one. The next one, this is our primary view. So everything that we can touch. Now right here is something a little bit different, and I want to talk about this. We have a circular cut, and if I extended these legs beyond the circular object, we would not have a gap to geometry. It's really important, you guys, when we have legs that would be on the same plane as a line, don't bring them out here. So erase a little gap right here, because yes, we go beyond the circular object, but we don't want to go way out here with it. We're just going to stop it a little bit short and do not connect to geometry. It's really important to be very clear as to what geometry is and what isn't. So this is an odd case. It's when we have a full 180 degree semicircle. Therefore, we don't have a leg up here because there's nothing curved up here. We only have three legs. This one goes beyond. This one goes out and just does not connect to solid geometry. We want the solid geometry to be as clear as possible. So that's something new for you guys. So then we have this entire object here, which seems pretty easy to understand, but when the center is right on the top of the plane, don't extend these out to the solid geometry. Alright, let's go to the right view this time. We're going to draw this 4 units deep. It's at the same height. These are in alignment, in other words, and 4 units deep. Now, any time that we have a hole on the side of a part, we have to have that view. So, you know, we've talked about how many views do we need. Any time that you have a hole on the side of the part, you have to have that view, because remember this, we cannot dimension things that to hidden lines. We cannot say what size this hole is here because it's hidden here. So it's just for extra geometry, for extra description. I cannot dimension the height of this. I have to do it here. The location here, because it's hidden in these two views. So I have to have this view for this cut, for this box, for this little notch, for this hole. There's nothing really here that I couldn't dimension here or here, meaning the length of this, the depth of this, so I can get the length here, I can get the depth here, I get the location and the size of this here. So I could get away with the front or primary and the right view. So I'm going to talk about that a little bit more as we go. Because not always, remember, do we have to draw the 6 sides of the box? How many views would I have to draw if I got to flat bid this drawing at $100? I don't want to draw 6 views. Remember that. So I've got this hole. It's right in the center. And once again, we have our center mark, and our extension lines go out beyond the circular object. They're not on an edge, so they can go out in solid material. This one is on an edge. These are not. That's the difference. So I go ahead and draw this circle. Draw all your visible lines. I've got these edges for this curve, and I can't tell it's a curve until I put that center line in. Now this is kind of an interesting thing. We have two things. I have hidden lines here going up, and they go all the way through, but they're not at the same height. Do you see that this goes all the way through and this is above it? So from this I can project this hidden line. I can project the bottom quadrant of that. So when this cut and this hole, which is also a cut, are on two different planes, they're not intersecting each other, right? So in other words, our hidden lines are going to go straight across each other and not stop at the other hidden lines. This cut goes all the way through and does not stop at this hole, right? So we wouldn't stop our hidden lines right here and then start on the other side. So when things are not intersecting in space, not running into each other, we draw it all the way through. Does that make sense to you guys? a little bit. Okay. So now we have this hole. We have our center mark. We have our axial center line. And remember, we can just put one big dash in there. And then your little bitty squares, it may look huge. But I can do one dash here. And then I can do one dash here. And we try and center those. So you might end up with a plus in the middle. And that does not mean anything. We don't put this ever in a square notch. So that wouldn't be like a center line of a square notch. We just put this only in circles. There is no axis to a square hole. Any questions on that one? On this next one, this is our primary view. This thing does go all the way through. You can kind of see the side of it. And this is called an isometric view or a pictorial view. So it's kind of nice to be able to see that. So we've got this notch going all the way through. We've got, this comes up straight, and then at this western quadrant, we have a full radius or a full round starting all the way around here. And then centered on this. So the center of this full round is right here. That's also concentric or has the same center of where that hole is. That hole is located right at the center of this full round. So we're going to use one center mark in a second for that. So we've got this, all these objects. I have to have this front view because of this shape, this cut, and this hole. In the right side view, I get my depth. That's something I can't get from the front. I can get that from the top view though. So then the height is the same. And if I'm just dragging a ruler down, I've got that. I've got this edge that's visible. And then just the bottom. If I have a ruler that's vertical, I have the end of the part. I have this vertical edge. I have a vertical edge right here and a corner right there. Then I have another one on the other side. And then the end of the part. Pretty simple part. We don't have any edges where, I'm going to show you this. These are what we call tangent, and it shows this circle with a line on it. And this is absolutely smoothed out right there. That's tangent right there. When you have a vertical line right at the eastern or western quadrant, or north with a horizontal line on the northern or southern, that is where it becomes absolutely tangent, and that would be smooth. If it stops above or below that, we would have an edge with a vertical line or a horizontal line. So that's absolutely smooth. So we don't have any edges on that. We don't have any edges for this radius. It's just smooth all the way around. Okay, so projecting hidden lines. I've got this for this hole. But what do I have this one? Well, if you go down here, we have this corner. And hidden lines override the center line. So I do not extend anything outside these two over here to show that it's also a center line. Just leave the center line off and override it with the physical edge of that part. Hidden lines override center lines. So we just don't put the center line. Alright, we have the top of this hole. The bottom of the hole is right in line with the visible line. So the visible line overrides the hidden line there. And to tell someone that there's something curved going on here, we'll put this center mark. But over here we have the top edge of this cut. So we're just constantly drawing back and forth, left and right and up and down. And when we're finished, we want to show the centers of the circular objects. So let's talk about this one. These two have the same center. So I'm going to extend this leg beyond the largest of the two concentric objects. Not just beyond the hole. I'm going to drag it all the way out to show that they have the same center. If I left them all right here, some people might think, oh, they forgot to put a center mark. So what's the rule on curves like this. If you have a full 180 degree round, you have to have a bullseye. If you have a quarter round like you see trim at Home Depot or Lowe's, it's just a quarter like that. You do not have to have a center mark. Only when you get to a full round that's 180 degrees. So on this one, I'm going to extend these beyond the largest of the two concentric objects. There is no arc down below that 180 degrees, so I just extend this beyond the hole. Now in the axial center line, it doesn't matter. That just goes and extends beyond the object. Alright, so we don't have a center line up here because it's overridden by a hidden line. Now we're going to move on to number 6. Does anyone have any questions on number 5? This is the time for you to ask questions to get clarity. Alright. Okay, thank you. So on number 6, this is our primary view. We see that we have 180 degree round that's cut all the way through the part, so we won't have a solid edge down here. If it didn't go all the way through, we would see the bottom edge of wherever it stopped. We have the whole outline profile. Now I know that I have to have the right side view. Why? Because I've got holes in it. So let's see. I can locate this full round here. I can say its size. So I have to have size and location for everything. I can say how high this is and how deep this is. I can get this whole shape pretty much dimensioned here, right? I can say how big it is, how tall it is, where this is located, maybe from one side or another. And we see that it's coplanar. It's centered right on the bottom by that center mark. On the right hand view, we have our depth. Let's say we have 4, and then it has the same height. But there's something that we could not touch here, which is this notch. And it doesn't go all the way through. So therefore we will have this top line all the way across to show the top of the back of that notch right there. So we've got this notch cut in, and we call that blind. We cannot see the bottom of it. We cannot see how deep it goes through. We cannot see all the way through the part. We have to measure the depth. Just like a blind hole, it doesn't go all the way through the part. Now I've got 2 holes that are on this face, so I'm going to draw those. And that's all that I can touch. In the top view, I've got this full plane of the top. That's this whole thing. I just drew this whole rectangle. And why do I have a rectangle right here? Because I will see this edge down at the bottom of that notch. And then I could project up and over, because we are going to be doing that in AutoCAD too. That's pretty cool. Then what can I get here that I can't get here? I can't tell how deep it goes right here. I can get that right here. So I need this view for the depth of that notch, and I need this view for the location and the height of the notch. Now I could get the location here and the width, but I can't get how tall it is right here. How deep does it go down from the top? How deep does this go in from the side? I've got to have both of these views to get this one notch. These holes go all the way through. I only need this view for it. But these holes, notice they stop right here. That's where the material stops, so the hole stops there. So notice that your hidden lines also stop right there. And these hidden lines start on the front. These are not intersecting, so it starts on the front and it's just down below that notch and goes all the way there. Same thing on the top. This one's a little bit harder to draw. So we've got this tangible edge. I can touch the top. Let me just clean all this stuff off. I can touch the top, but I've got a hidden edge right here. It is right in alignment with that. So I have a hidden edge right up to the touchable edge, and then it continues on through the back. And if you wanted to draw it all the way through, that's fine. The visible line's just going to override it. I have the same thing here, another hidden edge for that arced cut, and a physical edge that I can touch here. And of course, the end of the part. Okay, lots of lines in that one. So let's see what's going on. Let's see how we can make this a little bit more understandable. We've got this right here. We've got the top apex of this, the northern quadrant. Once again, we're not touching the curves on each side, but the top we can go all the way through because it will be on material and not on an edge. It's not, you know, when they're on the same edge, it's hard to understand what's going on there. All right, so I've got my legs extended for this one. I'm going to go over here and make these center marks. Now you could go ahead and connect these two lines if you want to. That shows that they're at the same height or they're on the same plane. What is this one? Well, this is this backside edge right here. And we have two holes that are on the same plane, so I only showed the apex or the northern quadrant and the southern quadrant of one of them because they're directly in alignment with each other. And I'm going to project this over here, and I'm going to project the depth down from here, and that will get me my hidden lines for my notch. So I've got to have this view for the profile and this cut. I've got to have this and this for this notch, and I've got to have this for this hole. So I would need all three views for this one. Anytime I put bullseyes in things, I'm going to have axial center lines. So this is looking straight into the cylinder. Now we're going to look at the axis of the cylinder, so that extends a little bit beyond. And once again, you can have just one dash if you want. But I want you to look at these. If I extend this up and over, I don't want to connect this with this touchable edge. I want to give a gap right there and then start my center line and then extend it beyond the object there. So I know this is a little bit confusing, especially if you just looked at the top of it. Sometimes we have drawings where we say hidden lines omitted, or left out for clarity. Anytime we don't have hidden lines for holes, we don't have center lines for hidden holes either, because there's no reason. You can't tell that there's anything there. So we would only have the center marks where you can see them. You would never have axial center lines if you didn't have hidden lines. Any questions on this one? So take a look at those gaps right there. Get those gaps in there. Because once again, this could be misconstrued as geometry. So that's why we don't connect that. And I'm going to stop this